We'll look now at how to apply loads to our model. And we've gone through all the effort of defining a model accurately, but if we don't represent our loads accurately, we won't get good results. Now, Altair has a number of different tools to represent different types of loading. And we can see we're going to focus on the top two right now, the joint loads and the line loads, but there's several other types of loading that can be represented and may be useful depending on your application. Now in our simple model here, we've already defined three load cases. I have self-weight, dead, and live loads. And I'm going to look at applying some loads using these two last load cases, dead and live loads. So I'll start off with the live load case in this situation. And for this load case, I'm actually going to use the joint load tool. So I'm going to left click on this tool to activate it, and you can see the data bar updates and gives me different ways of interacting with this particular tool. I can also right click on this joint load tool, and it'll bring up this dialog that allows me to define the magnitude and direction of my joint load. In this situation here, I'm going to specify a magnitude of a negative 100 kilonewtons, and I'm going to keep it in the Z linear force direction. So it's going to be going down, essentially. You can see the direction of Z. Now I'm going to press OK. And you notice that once I filled that information into that dialog, it updated the data bar. I could have done the same thing by just entering everything into the data bar. Totally up to you how you do that. And once I'm ready, I can just left click on a joint to apply that negative 100 kilonewton load to that joint. So I'm going to apply it to the tops of both columns, and this is part of the live load case. And for our other load case, the dead load case, which is our second one, or the second one I defined, I'm going to use a member load. And to define this member load, I'm going to use the global load tool. Now the global load tool is basically a way of defining a member load with respect to the global coordinate system. We also have a local load tool and a global projected load, and more details are available on those in the help system. Now with this global load tool selected, I can again configure the orientation, the load type. In this option here, we have the ability to define a fully uniform member load or a partially varying member load. And I'm going to define a partially varying member load. I don't want it to have the same magnitude along the entire length. With the partially varying member load here, I can define the direction, the orientation, and whether I want the loads to start and end relative to the member's length or with absolute coordinates. So here I'm going to use the absolute coordinate option. That's going to start with a magnitude of 0 at D1, so the first point where this load is going to start will be at 0.5 meters. And the end magnitude is going to be negative 5 kilonewton per meter. And that's going to be at D2, which is 4 meters, the length of this beam. I'm going to press OK, and I'm just going to left click on this beam to apply that load. And you can see what that looks like. It's starting at 0 at 0.5 meters along the length of the beam and ramping up to negative 5 kilonewtons per meter. Now I could have also chosen the relative option, and that would just allow me to specify these D1 and D2 locations where my loads are starting and stopping as a ratio of the member's length rather than an absolute number. Now this information has been applied graphically, but we could also do it through the spreadsheet window. If I go to the spreadsheet window here, you'll notice that there's a white hand button at the top of the screen. This allows us to switch between the loads and the geometry spreadsheet. And by default, the geometry spreadsheet will come up first. But if I left click on this, here I can see all of my load cases and the data within each. And then I can select my load case and look at the various properties. So I can look at the member load spreadsheet, and here I can see member number 3, which is my beam, how it's defined. So those are the member loads for member number 3. I can also look at load case number 3, which is my live load case. And I don't have any member loads, but I do have a joint load. In this case, I actually have 2 joint loads at 2 different locations at each 100 kilonewtons.